Welcome to another edition of Micro Welding Tech, the only podcast dedicated to welding at a micro scale. Subscribe today to stay on top of what's new in micro welding technology.
Welcome to episode 2 of the Sunstone Micro Welding podcast here. Today we're excited to talk about some welding solutions specifically in the battery welding world. Again, we have Dave Holloway here and Laren Dodgen and Thane Kennedy, myself, and we'll jump right in. Let's start with the basics. What role does a welder play in EV, electric vehicles, or manufacturing, and when it comes to batteries? And then even more specifically, why do you need a welder specific for batteries? Dave?
Yeah, I'll jump in on that one. So if we look at, we've got a couple samples on the table. These are just different cells. You can call them batteries, but technically these are just individual cells. A battery is formed when you then take two batteries and you join them together. You take the positive from one, connect it to the negative of the other, or I guess you could do positive and positive. But a battery, a pack, is formed when you take individual cells and join them. And that's where welding really comes in. How else do you connect this to this? You could clearly go top to bottom, but you can only go in a straight line at that point. When you add in and introduce a tab, you can then put that on top. And then what you've got is that continuation of the pack. And so how do you join that? That's where welding comes in. And there's a lot of different options we have. We've got resistance welding, which is typically the go-to of how to weld these. We'll talk a little bit later in the podcast about some new technologies that we've come up with. But essentially, to go back and answer the question, yeah, the welder is crucial. It's at the center of building battery packs. There's really no other good way to do it. You can solder, but then you're introducing heat, which isn't always good for batteries. So really, the welder is at the core of any business that's trying to weld up a battery pack.
Yeah, and soldering just creates a mess and is a lot more resistive, right? Just not a good method to do it. Welding's the way to go. So.
Yeah. Plus, from a manufacturing standpoint, solder adds a lot of complexity in the automation side and makes it difficult. Now, what we've seen in the market recently, specifically in the last 10 years or so, the shift from battery technology has shifted away from the NiCad and alkaline batteries over to the more lithium-based batteries. There's a lot of different chemistries and shapes and sizes, but those obviously have the ability to outperform their predecessors. But there's also some safety hazards, right? A lot of our customers have brought that up and kind of has a reputation for being unstable and potential fire hazard. So the question is, what's the real story? Should we be scared and terrified of lithium batteries, or are they safe?
Well, okay, there is a risk with the lithium. The reason everything shifted to lithium, though, let me address that one first. It's just the energy density that you get going from a NiCad. This is an old NiCad we were able to find, and then going into a lithium ion cell. You get so much more output for the same form factor. And oftentimes you can, if you have a smaller form factor, you can make a much bigger battery in the same space. So the move to lithium has been awesome, and it just continues to advance as we go. A lot of cool technology and updates coming into it. But you are going to see and hear of those horror stories of batteries catching fire, issues with thermal runaway. There are issues, but truthfully, if you go and do the research and look into the numbers, the percentage of batteries that are bad per million is very, very small. So as long as you're safe in your handling process and in your welding process, the fear really isn't something to be scared of. There's the chance for danger and concern with anything, and welding lithium batteries is no different. Sunstone does have a published white paper online. We'll include a link here as part of this podcast. But you can go and read that white paper. It addresses a lot of different things. It gives you an intro into what is lithium ion, how does it work, the difference between a lithium metal and a lithium ion cell, why we use lithium ions. It talks about safety in handling and welding, just general practices. If you drop a cell, what do you do? If you If you puncture a cell, what do you do? So it covers a lot of the things that you might run into when working with lithium ion. But in general, if it was that scary of a thing, you would not see these cells being used as prevalently as you are. And truth be told, every drill pack that gets sold nowadays has lithium ion cells. Most of the cars on the market, EV cars, have lithium ions in them. If they really truly were that dangerous, they would not have such a prevalence in the market.
And we have to remember the technology is in a place nowadays that we monitor these packs pretty well, monitoring voltage, temperatures, and everything as well. So we've got the backup to tell us that something's going out of whack, and things are in process so that doesn't happen, and it won't get to a point where it starts to flame and fire. So
Sure. So it could, yeah, in the past was probably a lot more dangerous than what we've come to see today.
Yeah,
for sure.
Most of us in this room, probably those listening, are listening with some sort of a lithium-ion device in their hand or pocket,
Correct.
on the wrist. All the craziness, and it's cool. Obviously, with batteries, the advancement in technology and where it's going, and just that's really where the cutting edge of really most devices are. We want more power. We want them to charge quicker, and the consequences of that research, right, and where it can go, the benefits we can see about charging quicker, electric cars being able to charge in a faster way and carry more power, more range, more torque. Really, you see that technology, the batteries and lithium specifically, is kind of at the forefront of all that excitement.
And it completely outweighs the little bit of a safety thing, but as long as you keep, like what Dave was saying in that paper, it talks a lot about it, keep those in mind, but that you just keep in mind and you'll be safe. It's a safe way to go.
Great. So the next question, obviously, we talked a lot about the battery chemistry, and Dave talked about the tabbing materials that we use to connect them. And so that's kind of the next question is, in the battery world, and we talk about connecting those cells with tabs, what kind of materials are they using to connect the tabs?
Yeah, so we've seen a lot of nickel in the past. It was like the number one exclusive. It has that silver look to it, but it's really good because it can be welded with a resistive kind of technology, resistive welder. And those systems are typically very automatable, very repeatable when it comes to welding over and over again. And so people have kind of pushed for nickel in the past. But what we've seen is with the welding technology that is coming about, and a unit obviously that we have that can do a very good job at welding the copper to aluminum and steel cans. And so whether it's the old nickel CAD, which they still want, or a lithium ion battery in a can, our systems we have weld that copper really well. And so one of those systems being the PA250, we can kind of mention that. It's kind of our third revision of system out there to do this. But yeah, the copper, being able to weld that all of a sudden opened up the industry to a whole new world where you're dealing with something that's a lot more conductive, a lot less resistivity to it, so less heat, right? And because of that, people it's gaining traction, and it naturally so, because why would someone use nickel over copper? We've had many reasons. I think Dave has a few good reasons why you'd want to.
Yeah, yeah. If you just look at the spec sheet between copper and nickel. So if we look at conductivity, you touched on, copper is 4 times more conductive. So that right there makes it desirable when you're building a pack for power and efficiency. If you can have something that conducts that electricity through the pack with less resistance, you're going to get better output. Thane mentioned just the charge times. We need things to charge faster. The copper is going to conduct that electricity through the pack much more efficiently, quicker than nickel. Larry was touching on some of our new welding products that are able to successfully weld the copper, and being able to make that switch, going from being able to weld the copper, that was the kind of the missing piece in all of this. With copper being so conductive, your resistance welder that Larry touched on earlier, it's hard to weld it because when you try to put energy into the copper, it just wicks it away, and it doesn't actually overcome the metal and melt it to the tabs. In fact, when you weld on our nickel tabs here, you're typically using a copper electrode because of how efficiently it conducts energy. You can't weld copper with copper. But the Omega pulse arc welding system, it uses an arc weld process and can melt through the copper and join it into the cells really successfully. So that's kind of the shift that we're pioneering here with the copper tabs. But just going back again, let me finish 2 other points. The copper is 4 times more conductive. We can typically weld thicker tabs now, whereas an industry standard 5 or 10 thousandths thick nickel tab, we can now weld a 20 thousandths copper tab. So not only is it 4 times more conductive, but it's twice as thick, meaning it can pull more. And then just your cost per tab, depending on spot price, copper is usually about a half to a third the price of nickel. So there's a cost savings as well. If you get into making big packs, putting copper into the pack is going to save on the bottom line as well.
Very cool. Now, obviously, we talked about the battery and the advancements there, and obviously we can't use the same tab. As batteries get more and more advanced, it doesn't make sense that we wouldn't be able to use the same tab, the same welder, the same joining process that we did. The tabbing materials got to advance at the same rate that the batteries are advancing, and the technology to weld that as well. So what has Sunstone specifically, I know Lauren made some mention to that, but what has Sunstone done specifically to help take advantage of copper in the battery world?
Like Dave was saying, with the copper, we can weld a thicker tab. The biggest thing with the battery packs and the thing they deal with is heat. One of the big advantages of copper is that it doesn't allow the heat to build up between the joints, right? So you're going to have a tab that goes between the 2 batteries, and that joint between the 2 is going to have current going through it, and that which is going to cause heat. But being conductive, the copper is going to throw off a lot less heat, so you're not losing as much power through that path. So more power can go into the pack, right? More power can go to whatever you're using the pack for, which can be used for many different reasons. I mean, the car is one big one that comes to mind right away, the automotive industry. But I mean, there's battery packs for handheld items too, drills and whatnot. And so the biggest thing that they have to deal with is heat. And just for that reason alone, copper is way better than nickel in those regards. And that's also keeps the lithium batteries from overheating as well. And so yeah, it was just a natural progression to go from nickel to copper because of all those specifications that need to be met during the time.
Yeah, and you mentioned the Omega battery welding system earlier. How are those welds? How good are those welds in comparison?
Yeah, so I mean, I think we have some data over there, but the spot sizes you get with the EV system are, I think, 4 or 5 times as large as you can get with a nickel and a resistive welder. And because of that, the strength is amazing. The 4 or 5 times the strength, or maybe up to 8 times the strength in those welds because of it. Because your spot, the amount of surface area that you're coming in contact from the copper to the tab and the cell itself is just way bigger than you can do with the resistive welder. And so now that's another aspect to it that makes our PA250 system just a no-brainer to move to because of that reasoning. You can get 1 or 2 spots in there and you're done, you know. And that second spot's there just for rigidity, but you really only need 1 spot in order to make what 4 to 6 welds with a resistive welder would be. And so it's a little bit more efficient that way too.
Yeah, and where our welder technology is different and new, and where the tabbing material is new, you're asking what do those welds look like? One thing we've always had, it's something you can always call in and ask for. We'll send out, we'll weld up, we'll take an empty can like this, there's nothing in it, so there's no potential for damage or concern. It's just looking at the casing, and we can send out some welded samples, put a copper tab on there, make some welds and ship it out, drop it in the mail, so that customers and potential clients can see for themselves what the welds look like. Go ahead and do a peel test, a destructive peel test, to see the size of the nuggets that are left behind. So again, I'll make sure we have that link shared some way with this podcast so people can ask for a free sample.
Very cool, very cool. Now, Laren, during the development, obviously this is a technology that's probably fairly new for some people. Maybe the first time they've heard about welding copper and that process, but here at Sunstone, it's not necessarily a new concept. It's not something he just released here. Obviously, we have a newer rendition of that machine. But what were some of the challenges as you worked on the Omega battery welding system? What were the major challenges, and what did we do to kind of overcome those?
Yeah, so one of the challenges at the very beginning, our first system that we came up with was consistency. And the main reason being there was a lot of things that stacked up and caused that variability to come up into the solution for welding. And so our tungsten electrode that come down to the surface, if it had contaminants on it, or the previous weld knocked a little bit of tungsten off, then it would be a little shorter. And it was just driven by a solenoid originally. So we found out very quickly that it wasn't a solution that could just be done with a solenoid. We needed to have some way of controlling it better. So of course we went naturally to a motor, a stepper motor design that would allow for variability in length of the tungsten. And so now with our current system, we have that ability to be able to adjust when it comes down and when it touches. And so it doesn't matter what tip length you have, it can be variable within an eighth of an inch up to three quarters of an inch and as long as it's within that realm, then it can weld, and it will weld really repeatedly at that point because it knows where it's at. So that was one thing that was a challenge originally to now the new system we have. Some of the other systems was the ignition. In order to ignite, you have to kind of have a little bit of a current, we found, in the beginning of the ignition process. Originally, we weren't doing that, and again, we would just get tons of misfires because the plasma wasn't able to discharge correctly. But now with we had that in the second system, but even better and more so in the third system, we've created a what we call advanced welding ignition. But essentially, it allows a certain current to flow through, which we have variability on that. We can control how much current we're going to have flow through that, depending upon how much energy is the actual weld. So depending upon the weld energy, we can throw a little bit of a low current ignition across there where it starts the arc, and that little tiny arc is formed as the tungsten electrode comes off the surface. So when it comes down and pulls up, it creates a tiny arc that can be maintained. And it's only 10 to 25 amps, can be down to 5 amps as well, but a very low current. That's why we call it low current ignition here internally. But because of that, it maintains the arc and the tip shape stays clean because now the tip is completely lifted off the surface before a weld begins. And then at that point, the weld will discharge once it knows it's lifted off and it's off the surface. It'll make the weld at that point, which then creates a huge plasma arc that is really high in temperature, that 4,000 to 5,000 degrees Celsius, kind of the surface of the sun type temperatures that can then melt many different types of metal, and copper being one of them because it's so fast and so much heat at once. The copper, even being as conductive it is, still succumbs to that and is able to be welded at that point. But that also created a situation where our tungsten electrodes could then be a little bit more clean after every weld. They weren't getting contaminated as much, and the contaminants not being on the tip helped a lot. And so that was a couple things that we kind of, as we were developing this, that we ran into that created a little bit of an issue, but we're able to solve that with the PA250 for the most part. So now, you may get an occasional time where you have to re-weld, but it's a lot less than it was originally with our original system for the EV welding. So
lots of work and time put into that development. Now, obviously, like I said, these customers probably haven't heard of this or seen of it, and this might be new to them. But is this new to everybody in the world, Dave, or are there other people who've had success with this?
Oh, gotcha. Excuse me. No, we've had the system for a number of years, and we have had a lot of interest in it. Early adopters, pioneers that bought the system. They really showed us what they could do with it. A lot of our customers, may have an NDA in place, so I can't share all the names and all the people, all the applications. But we've had a lot of fun times, a lot of fun experiences working with customers from multiple collegiate electric go-kart competitions where we've been able to sponsor them and play a role in them building a better pack and seeing success that way, to other clients who kind of take on just different jobs related to EV vehicles. There's a company in particular they've made custom scooters. They've converted multiple cars from a gas engine to an electric engine, They've done a project where they converted a vehicle to be a battery-driven vehicle that had zero emissions, and the reason they had to do that was because these vehicles go into mines where you can't really have emissions in the mine because it'll never clear out. But having an electric vehicle drive through a mine shaft with zero emission kind of overcomes it and opens up tons of opportunities. There are two companies that I will specifically mention by name. They're already on our website. There's a company, Vantage Power, over in London. They actually converted city buses from gas to electric, and we have a customer spotlight video of them on our website. We can include links for that. And another more recent one is Vextrek. We've got a guy named Gary Little who's making new electric go-karts, and these things are quick. They are speedy, and so we've got some social media posts and some highlights with him as well. So a very wide net of different customers doing different things, all related with EV battery packs. And it's pretty exciting to be able to partner with them and see what they're able to do with our technologies.
Very cool. Now, as we just wrap up, I just wanted to go through each of you and just ask, are there any other key features to the Omega or things you just want to share with the Omega specifically and that the customers might want to know? Larry?
Yeah, we've mentioned a few things. I think, like we'd mentioned before, it's kind of our third rendition of a system. So we've been doing this for 6-7 years now. And so now we've learned a lot, and the PA250 is a conglomerate of what we've learned and things we've had to overcome to get to where it is now. And so of all of our systems, of course, it's the best one because it's the newest, but with that system, it's even more repeatable. It can do things that we haven't been able to do in the past. We've also had problems with sticking electrode to the battery cells, right, which is like the number one no for building battery packs, right? And so we concentrate a lot of time on the PA250 to ensure that electrode would never stick to a battery. And so that was something we focused a lot on engineering to make sure that customers could feel like they could be on that 1,001th weld and it doesn't stick, right? So, sometimes we'll misfire and you'll have to repeat that process. But the cool thing is with the Omega, you have the ability to do that, right? You have the ability to talk with a robot, or a table or PLC, and be able to communicate, saying that, hey, that last weld didn't happen, let's try that again. And so the worst case scenario is you have to just try it one more time and then it welds and continues on, right? But you'd rather that than have your electrodes sitting there stuck on the battery can. And so that's why we erred to the make a false weld rather than accidentally sticking occasionally. And because of that PA250 is where it's at today, which is that it makes amazingly consistent welds and it'll just weld all day long. And only having to sharpen that tip occasionally. So
Very cool. Dave?
Yeah, I think what I like about it is if you look at what we've done on a software side and the usability, it's got a giant touchscreen up in front that has all the controls at a glance, one touch access to all the different parameters. We've done quite a bit to get the customer up and running quickly. We've done extensive testing with different materials, with different cell thicknesses, and we've even got kind of a templated quick start guide. You select the material of your can, you select the material of your tab, the thicknesses of each, and it'll generate a starting point for you. Obviously, we can't predict every setting for you for every customer, but it gives you a general starting point based off of actual data that we've done, days and days of us doing different samples. So that's one thing that I love selling when I sell the machine is I tell them it's pretty easy to get started. The other feature that I love is the versatility of it. You could be welding different materials one day and then switch over to different ones the next day. And the machine isn't just a one-trick pony. You really can do a lot of different things with it. And not only just the weld settings, but even the configuration. You could start with a kind of a manual benchtop style weld, and let's say the project takes off and the funding comes in, you can take that same core welder and convert it into an automated system like Larry was mentioning. So it really is a machine that can grow with you and unlock new opportunities. And as batteries and the packs continue to progress and evolve, this is a machine that's got a place in the future.
Yeah. Well, you can definitely tell from our conversation the amount of effort and time that's gone into these solutions and finding something that's going to be a good fit for the customer and delivering a good, solid solution that's going to meet their needs. So, but certainly if you're interested in battery welding in any way, we have a lot of resources on our website, and don't be afraid to call in and talk to our guys on the phone. They'll be able to walk you through and give you a training if it's your first time, or if you're an expert and you know everything, right? It certainly doesn't hurt to give us a call, and we'll consult, and we do that for free and offer that as a service. But other than that, covers our topic. We look forward to our next time. Join us. But thank you for listening.
That concludes another edition of Micro Welding Tech. Got questions, comments, or topic suggestions? Call or text 801-658-0015. Remember to subscribe today to stay on top of what's new in micro welding technology. Thanks for joining us.